Hello, welcome to your OSL640 Week 7 lecture. I'm going to have to see how things are for time when I get to the second video because I might end up doing 3 videos this week. We'll have to see when we get there. The third one would be talking entirely about your project. I think it's going to make more sense to do 3. So this week we're looking at how to install Linux, different ways you can install Linux. Linux Live distribution, and why you would do this, and you're going to actually look at in the tutorial this week how to install a Red Hat Enterprise Linux virtual machine, which is pretty cool. So having Linux on your home computer, if you're going to learn Linux, the best way to learn Linux is by using Linux. Having it on your home computer gives you access to a whole bunch of open source software that's also largely free. Like 99% of the stuff, I don't think I've had to pay for any open source software, come to think of it. Everything that I use is free. And you can install this on your notebook, laptop, or desktop, and it will teach you how to work in a Linux environment. It'll teach you about running different graphical applications and performing like simple Linux OS administration tasks. You know, installing updates, configuring backups if you want files backed up over the network, depending on the complexity of your setup. So to install a Linux distribution, just like a traditional way you would install it on a computer. First, you have to go and select your Linux distribution that you want to download. The example in the slides is Knoppix. I use Linux Mint at home, as you know. So you could go to the website for the distribution you want to download, if you happen to know which one you want to download. If you don't, I'm going to show you a handy website here, distrowatch.com, and it gives you the top Linux distributions based on page hits. And if you want to download one of these, let's say, so see Mint is right there. You can just click that, and it gives you a bunch of information about Linux Mint and the website for like the homepage. So all kinds of useful stuff there. Distrowatch.com. Once you've got the ISO downloaded, you need to then either burn a CD or DVD, or more commonly make a bootable USB flash drive. And there's instructions here on how to do that. Most distributions give you a guided graphical installer, and it's a lot like installing Windows, or I imagine Mac OS. I've never installed Mac OS, but it's like installing any other operating system. It's pretty straightforward. Read the options at each screen, pick the ones that apply best to you. Very point and click. You're going to get to actually practice with this in the tutorial this week, installing Red Hat Enterprise Linux as a virtual machine, though, not as the host operating system. So you could install Linux as the standalone operating system, meaning that it's the only operating system on the system. And if you're doing that, any data that's on the disk is going to be wiped. So you want to have backups of all of your pictures and documents and whatever else you've got to back up before you go ahead and do this. Again, you might want to do this in later semesters on an old laptop if you've got one kicking around. It's a good way to breathe some life into some old hardware. Or if you're actually building your own desktop. I mean, I've built every desktop I've owned for the last little over 20 years now. If you're building a new desktop and your old one is kicking around and still works, maybe you want to make it a server of some sort in your house, so you could go ahead and do that. Alternatively, you might want the ability to use your existing operating system alongside a Linux installation. So this is what's known as dual boot, or you could have more than one operating system, hence multi-boot, right? So you could have Linux Mint and Windows, or Ubuntu and Windows, or you could have a couple Linux distributions and Windows. The advantage to this is if your Windows operating system, usually that's the one that goes corrupt, if your main operating system fails to boot, you can boot up the Linux partition, access the window partition, and copy any of this stuff over. It's also pretty good for troubleshooting. The only real drawback to this is it takes up more hard drive space, and you have to set aside parts of your hard drive for the separate operating systems. So you have to kind of keep that in mind. You want a bigger hard drive. If you've got a small hard drive, this isn't going to work. If you're going to do a dual boot installation, which we're not covering either a standalone or dual boot installation in this course, this is just theory. You should back up your data first and install Windows first. Let it do its thing, let it take up all the resources, do whatever it wants. And then install Linux second, whatever distribution you've picked. And that way you can customize Linux, and it plays a lot nicer than doing it the other way. So yeah, install Windows first, then install Linux second if you're doing a dual boot setup. The third option, and you've already done some of this in your OSM, I want to say 620, your introduction to Microsoft Systems, Windows course, is to install virtual machines. You've seen me use one all semester, well, one or two, because sometimes I use my Linux Mint virtual machine, as I like segregating the traffic for Matrix from my host operating system. Or you've seen me use my Windows 10 VM a few times when I was having issues with the Linux Mint one connecting to Matrix, which I think I've got resolved, so I'm probably going to go back to using that one. But we'll see. So with a virtual machine, this allows you to run a virtual instance of another computer system within your system, and it gives you a layer of abstraction from the actual computer hardware. The guest operating system is installed and run in a separate window on your host's operating system. And you need some special software to do this, which they're all referred to as a hypervisor. This could be VirtualBox, which you've seen me use. This could be VMware Workstation, which you have used for your Windows course, and you will be using in Tutorial 7, again, which is great. You don't need any additional software here. There's other ones out there too. KVM comes to mind. So advantages to having virtual machines is you can run a VM from just the ISO file. You don't need to make a flash drive or burn a CD or DVD. You can also just download virtual machine files, port them around to different systems. You can find some of these on the internet. Careful if you're downloading and testing something on the internet. And you can have multiple virtual machines at the same time, assuming your computer's hardware has sufficient resources. You have additional RAM, you have additional cores in your processor that you can allocate to different virtual machines. So this allows you to, for the purposes of learning networking, it allows you to create more of a simulated network test environment to set up different servers and have them communicate with one another. And you're totally going to be doing this in your, well, you're already probably doing it in your Windows course, but you're definitely going to be doing it in your later semester courses in this program. You have to keep in mind when you're doing this that your guest operating systems, your virtual machines, share all of their hardware with the host operating system. So keep that in mind as you're installing and spinning up virtual machines. Typically you allocate one core, at minimum one core per virtual machine of your processor, And you always have to remember to leave at least one core on the host for the host operating system. If you go over that, you don't leave one for your host, then you might run into some problems. Your entire system might freeze up. So keep this in mind when you're trying to figure out how many VMs you can run. For example, if you have a quad-core processor, well, you can run at most 3 virtual machines, 1 core per VM plus 1 for the host. I've got a 6-core processor, so I could run at most 5 virtual machines at one time. As you have more of these on at a time, your computer's going to be a little bit slower because they're sharing resources. So just keep that in mind. Be aware, and you can actually do a lot of things with just 3 VMs. A very, very wide range of fairly advanced things with just 3 VMs. So that will do most of what you need for this program, I think. I don't know, because well, some of the upper semester stuff really hasn't been developed yet. All of the guest systems too, like they share processing power and virtual hard disk space and memory with the host, all of their network traffic passes through the host as well. So if you're going to install some VMs, you have to make sure that your processor is compatible with virtualization and supports it. Not all processors do, but most do. And you have to make sure that you go into the BIOS settings and enable virtualization. This is usually disabled by default. It's an extra step to go in there and do this. And I already mentioned popular software for virtual machines are, of course, VMware and VirtualBox. Those are 2 separate ones. Aside from these, you can also run Linux off a live CD or DVD or USB. So what this does is it gives you a bootable Linux system that exists solely off the medium you're booting off of, be it CD, DVD, or USB flash drive. And you boot into that environment, it's only running in RAM. You're not overwriting anything on the system itself. And any files that you work on, anything that you do, you're going to have saved on additional storage somewhere because it's going to be gone as soon as you shut down. But this can be great for a couple things. First of all, if you're having issues with either your hard drive or something's wrong with your main OS and you just want to get your data off it, your OS isn't bootable. You just want to get your data off the drive so you can format and reinstall. You can boot off a live CD, mount the disk, or again CD, DVD, USB, whatever. Mount the disk, back up all of your data to another external drive, unplug that drive, and then reformat the system, reinstall everything. It also gives you the option. I did this a couple times where I had hard drives fail, and it was the boot sector on the hard disk that failed. If I'm going to return it for a refund, because I actually did this once where I had bought a brand new hard drive and it failed within the first like 6 or 7 hours. I had finished installing everything. I installed the operating system, a whole bunch of programs that I use. I got everything set up. I got all my data backed up or restored from backup. And I went upstairs, had a nap, got some food, did something for a little while. Came back downstairs a couple hours later. It didn't boot. It was a defective disk. There was a problem with the boot sector. So naturally, I was going to take it back to the store. I had the receipt and everything. I just bought it like that day. Take it back to the store and exchange it for a new one. But I didn't want to give them all of my data. Not that I had anything there that you don't like giving people your data, right? You might have tax information there. You might have like pictures. It's personal stuff, right? So I booted off a live CD, wiped the disk, deleted the partition, made sure that there was nothing on the disk, and yeah, they can still recover that if they use the right diagnostic tools, but it's clean enough for most people. Put it back, took it out, put it back in the package, walked back to the store, swapped it for a new one. So it was great, and I couldn't have done all that without a live CD. So there's lots of good practical uses for requiring these. And again, I don't think anybody really uses CDs anymore, but even DVDs now, most computers don't come with a DVD drive. There is no optical drive built in, so you're probably using a USB drive. Now in tutorial 7, this week's tutorial, you're going to install Red Hat Enterprise. You've got all the information in there to do that as a virtual machine. And having a VM installed could be useful for testing server configurations, for writing code or testing code in a virtual test environment. For example, if you need a database but you don't want the database deployed on your existing VM machine, you tend to test these things in a development environment or test environment before you deploy them to a production environment or a live server environment. So in this week's tutorial, you're actually going to get to install Red Hat Enterprise Linux and install some of the software within that VM and connect it to the Matrix server. And you're going to use all of these skills in OSL640. I don't know if you're going to be using Red Hat's Enterprise Linux in that course, but you're going to be having virtual machines, or you're going to have to install some VMs, you're going to have to install software, you're going to learn how to administer Linux systems. And do some basic networking with them. And I picked Red Hat Enterprise Linux for this tutorial. This is the one tutorial that I completely rewrote from scratch, so hopefully it turned out alright. I picked Red Hat Enterprise Linux because it is the most popular Linux distribution on a server in North America. So that's interesting trivia there. So you can get practice with all of this stuff with the 3 investigations in your Week 7 tutorial. They'll walk you through creating a Red Hat account, which you need, and installing the ISO, or downloading the ISO, sorry. Creating the virtual machine in VMware. I wanted to make sure that link worked, that's why I did that. And then installing Red Hat Enterprise Linux in VMware using that ISO that you download. And then lastly, we're going to install the Global VPN, or Global Protect VPN software, and connect your VM to Matrix. And then you're going to create a file and run a check script, and that's going to check the whole thing for you. And there's some Linux practice questions in there. This is going to be a very, very important tutorial, as I've mentioned a few times this semester, because it's going to give you the foundation for your project that I'm going to talk about a little later. And that's going to bring us to lesson 2, so I will see you in the next video.